Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 26. We are continuing our investigation in trigonometry. In particular, we're going to look at the cofunction identities now. So, in the previous episode, we looked at right triangle trigonometry. Very exciting. Let's draw a bigger triangle. Delete. Alright, nice big triangle-ish. Alright, so we have, let's call X, Y, and how about H for hypotenuse? We talked about how this was adjacent, and this was opposite, and this was hypotenuse in the previous episode. But now what we want to do is talk about what's called the cofunction identities. So when we talked about when we talked about graph transformations of sine and cosine, and just talked about the functions of the 6 trig functions in general, we observed that it appeared that the functions were shifts of each other, horizontal shifts like sine and cosine, tangent, cotangent, secant, and cosecant. And that's precisely what the cofunction identities are all about. So we're going to call this top angle here phi. Alright. So if we think about sine theta, that's equal to x over h. Well, we could also think about it in a different manner here. So if we think about now this angle theta, right? Oh, what did I say? X over h? That's silly. Y over h. There we go. Y over h. I like that better. So when we think about y over h now, right? We must make an important note. So here I labeled opposite, hypotenuse, and adjacent. That is in reference to this angle theta here. Now, we have to be careful because adjacent, opposite, and hypotenuse are actually relative terms, and they are relative to your angle of reference. So for example, if this was our angle of reference, this is actually adjacent and this is actually opposite. So in other words, we could think of this angle or this quantity y over h here as equal to cosine, right? Cosine of phi. Because notice, cosine of phi is adjacent over hypotenuse, and adjacent is y, and hypotenuse is h here, right? Now, if we make another note that phi plus theta plus 90 degrees is equal to 180, or, right, because all three angles have to add up to 180 degrees. So if we subtract 90 degrees from both sides, that tells us that phi plus theta is equal to 90 degrees, or that phi is equal to 90 degrees minus theta. So if we now put it in terms of radian, phi is actually going to equal pi over 2 minus theta. That is the cofunction identity. So since we have sine theta is equal to cosine of phi, that means this is also going to equal cosine of pi over 2 minus theta. And that precisely is what we talked about earlier about the horizontal shifts of sine and cosine. And this proves here that we have the horizontal shift by pi over 2. That's the relationship between sine and cosine. Alright. So sine theta is going to equal cosine of pi over 2 minus theta. And we can also state it in this manner. Cosine theta is going to equal sine of pi over 2 minus theta. The two are very similar. And we can actually do this for all 6 of our trig functions, which is pretty cool. So let's see here. So we got tangent theta. We can perform the same kind of analysis, right? Tangent theta is equal to y over x, but that's the same thing as cotangent, right, of phi. So tangent theta is equal to y over x, but this is equal to cotangent of phi, because phi is adjacent over opposite, and cotangent of phi is the same thing as cotangent pi over 2 minus theta. So that means tangent theta has to equal cotangent of pi over 2 minus theta, and we can form the same analysis. Cotangent theta is equal to tangent of pi over 2 minus phi. You can probably guess where this is going. Secant theta, let's see here, secant theta is 1 over cosine. So let's say here, secant theta is equal to 1 over cosine theta, which is equal to hypotenuse over adjacent. Hypotenuse over adjacent, that's h over x. And notice that is the same thing as cosecant of phi, right? X over, or h over x. So that's equal to cosecant of, cosecant of phi. And so that shows that cosecant of pi over 2 minus theta, same thing as secant of theta. Cosecant theta is equal to secant of pi over 2 minus phi. So that confirms what we talked about before. And now we have 6 more trig identities to have fun with. Alright, so these will be useful pieces of information when we eventually get to proving trig identities. For now, we're just getting our building blocks all set up for that. Well, with that, we're going to conclude this video. Thank you for watching. If you've been enjoying our content, subscribe, support us on Patreon. Thank you for joining Math Party, and we'll see you next time.